Welcome once again. Today we'll be looking at the general case for mass transfer, where we want to develop a general equation that we can now make use to calculate the molar flux of diffusion for a particular component. All right. So to kickstart, we need to look at the two pillars of mass transport. So mass transport can occur due to molecular diffusion, which is the random motion of particles, which is relative to the molar average velocity, then due to the convectional or bulky flow, which is the movement of the entire fluid stream, which will be carrying all the components along. So then total flux becomes the sum of transport due to the concentration gradients plus transport due to the bulky flow. Right. So the general equation for the total flux is we are developing this relative to a stationary coordinate and is the vector sum of its diffusive flux relative to the bulky and its convective due to the velocity of the entire mixture. So our total molar flux Na is equal to diffusive flux, which is also our JAB there. So this is our JAB. Then plus our convective flux. So this is indicated in our equation 1.3 1 there is indicated there. Right. So two critical special cases come into play where we apply the general equation. So two special cases are special case number one, where we talk about the equimolar counter diffusion, where it's a condition for every molecule of A diffusing in one direction, a molecule of B diffuses in the opposite direction. So here we've got Na equals to minus Nb. So what does this mean? It means that the total flux Na plus Nb becomes 0, causing the convective term to vanish from that equation. Then the simplified result, the total flux is equal to the diffusivity flux. So Na becomes equals to Ja. Then a special case, which is number 2, which is diffusion through stagnant B. So component A is diffusing, but component B is stationary. Then that means Nb is equal to 0, and impact on the equation is component A must push the bulky, making the convective term significant. So common application is it where we have our gas absorption and evaporation of our liquids.